Hi, good morning, everyone. Good afternoon. This is IM2, and we're in Unit 7, Lesson 1, Investigation number 2. All right, today we're talking more about SOHCAHTOA. All right, so we're talking about SOHCAHTOA. So yesterday we looked at this problem and we looked at this acronym, and we're just going to be applying it to a couple different things. So let me take a little picture of this so we have it. Sorry that was loud if you're listening with a headphone. I know that was noisy. All right, so SOHCAHTOA. So SOHCAHTOA just means that our sine function is the opposite side over the hypotenuse. The cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And this works for any right triangle, okay? So this works for any right triangle, and we're going to be looking at this right triangle here. And we want to write the expressions for these three things. We're going to look at this problem right here. Write the expressions for tangent of B, cosine of B, and sine of B. Send to current page. I'm sorry that's so noisy. I know if you're listening with headphones, when they take that screenshot, it's probably very loud. So we're doing tangent, cosine, and sine of this, I feel like this triangle right here. So let's get this like neat and organized for you guys. This triangle. Let's take a little picture and put it here. Okay, that's what we're going to be working on. If you want to pause the video for a second and write down this. So we have explain why tangent of A. So if this is A right here, okay, is the length of the side of the opposite. So opposite on the other side of. So this is your opposite side. Okay, opposite over adjacent, adjacent next to. Okay, opposite over adjacent, A over B here. Sine is the opposite of the hypotenuse. Hypotenuse is the longest side, so that's our hypotenuse in reference to A. Now we're going to notice when we start looking at B, our whole perspective changes, right? It's kind of like, you know, if you ever go through like a major life event or something like happens in your life, all of a sudden your perspective changes. Maybe since we're home right now, due to this COVID-19, we're thinking our perspectives on some things are just a little bit different, right? But now we're here at A and now we're up here at B and our perspective is different, meaning that now all of a sudden when we look on the other side, we see something different. Now on the other side, our opposite side is now switched to B. You guys see that? And our adjacent side, our next to side, ADJ, is A. And our hypotenuse is still always the longest side. All right, so when we go to find our sine, cosine, or tangent of our B, that's what we're going to be using. So I'm going to send this to new page. All right, that's what's going to happen. So let me just make this the right size. Boom, boom. Okay, there we go. So we have our tangent. So we'd have the tangent of B is going to be equal to the opposite over the adjacent. TOA. So B over A is equal to B divide A. All right, our cosine of B, I'm just trying to go in the same order that this is given. The B angles are up here. The sine of B is opposite over adjacent, so that's B over C. Okay, and then our cosine of B is adjacent over hypotenuse, A over C. A divided by C. All right, so that's problem, I think 1B or 2B, right, 2B, okay, for this section. All right, so we're going to take a look a little bit more about, wait a minute. How do we get all the way over there? Oh, here we are, okay. So we're going to be looking now, this is an example of where we would use trig, okay. So let me make this really big so we can see. So Chicago has this bat column, I guess they're saying. It's a bat. All right, and this is a situation where we would use trig to figure out how to solve this, right? We would use trig or sine or cosine and tangent to figure out, well, a couple different things, okay? If we wanted to find the length of a certain side, right? Like the height of the bat or something, or maybe it's something that's growing like a tree. Like hopefully when they created this, they knew how tall it was going to be before they built it. So this is maybe a silly question, but that's one situation where we would use these types of problems. And then that's what we just did. Then we have, let's see, some people, Kristen and Dewan, proceed as follows. First, Kristen chose a spot 20 meters from the sculpture and estimate the angle of elevation. So he used like a protractor to estimate the angle of elevation to be 55 degrees, right? What is the measure of B? So let's take a look at kind of what he was thinking when he did this. So this is his thought. And who was it? Dewan? Oh, they did. Oh, they were thinking, hey. So let's see. So this is what they were thinking. Let's send that to a new page. And let's get a little picture of kind of like what they did with this protractor, because this is fancy stuff. All right, this is kind of measured angle of elevation. Okay, all right. So let's see. Send that to clipboard. Edit, paste. Okay. So here's what they discovered. They said, well, it's about the 55 degrees up, right, from the angle up, right? So they said this is about right here, 55 degrees. Oh. Okay, that's what they said. And by using a protractor. And tangent 55 is 1.4287. Okay, so we'll talk then. AC is 20 meters. So AC is 20 meters. So let's see. What was AC in our picture? Let's go back to our bat column. Let's look at the bat. Oh, AC is 20. So he's 20 meters away, right? That's 20 meters. So let's go. Let's go. All right. So from AC, so here's A, capital A, and here's C, capital C. And the distance from A to C is 20 meters, right? So this is 20 meters. 20 meters. Okay, cool. That's what he says. So, so we know that tangent of 55 is equal to the opposite AC over BC. So this is ABC. If you didn't get a copy of it down, like I didn't get a copy of it down, BC. So tangent, we know, we just talked about how tangent is TOA. Okay, so tangent is the opposite over the adjacent. So that's what he's thinking. Tangent is the opposite over adjacent. So tangent is whatever this side is over the adjacent side. Okay, so he wrote a sentence and he said, look at my handy dandy sentence. Tangent 55 is BC over AC. But I know what AC is. I know AC is 20 meters because he measured that he's 20 meters away from the tower. So he gets this whole equation. He gets that your tangent, and we'll talk about that decimal in a second. Tangent of 55, okay, is equal to, this is how I would write it, the opposite side over adjacent, but I know adjacent is 20. Now I have an equation. It's got one unknown in it. It's the opposite. I can solve it, all right? Now you might be thinking, well, what's this TAN 55? You could figure this out. You could use the table, or you could go to your calculator, and you go to second. Just make sure your mode is in the right mode. We want to make sure that we're in degree mode, which we are. See, it's in degree mode right there. And we would go to second quit. We just hit this, boom, tangent by 5, enter. Okay, and we get 1.42. That's where that number comes from. Let me take a little screenshot of that. And I see that our meeting is open, and I feel like I hear somebody. So I'm going to put this on pause for 1 second. And edit, paste. Okay. And we're going to pick this back up in 1 second, all right? I'm doing this during our class on Thursday. So somebody had signed into that meeting real quick. All right, so we have tangent 1.428. So we're just going to replace this tangent 155 with 1.4281, 0.428. And those of you who will one day take an AP class, 3 decimal places is preferred. So I'm going to round to 3. Even though it's, yeah, well, they do 4281. Man, fancy, 20. So now we just want to solve this equation. It's easy. We just multiply both sides by 20. 20 times. These cross out. And then we have our answer, okay? Our opposite side, or our BC, is equal to whatever 20 times 1.4281 is. So let's do that math. 20 times that, yeah, 28.56. Let's take a little picture. A little snappy snap. That's what we get. So 28.56. So that's our answer. 28.56 or 29. About 29. I mean, it's all an estimate because he's estimating that right there. About 28.6. Okay, meters. Okay. All right, and this is the process we're going to go through. All right, I'm seeing we're getting close to 11 minutes. So I think we're going to pick this up and look at our next video for some examples. We're going to be looking at examples that look like, I know I have some like real specific triangles I want you guys to look at. Let me just try to find them. Right here, where we're given like out of context just triangles and trying to find for the missing side S. That's what we're going to be doing next, okay?